Hey folks, welcome back. Rational expressions and equations, lesson 6, division of rational expressions. So what we need to remember about dividing rational expressions is really how do we divide fractions, right? And then what are some of the things that we need to remember from bed mass or for bed mass? Okay? So divide 7 over 10 divided by 3 over 14. What you have to remember is that we end up when dividing by fractions, we multiply by, so we change this to multiplication, multiply by the reciprocal, and we flip the second fraction, 14 over 3. Okay? And then you just multiply as normal, straight across the top, straight across the bottom. If you want to cross reduce, you can cross reduce if that's going to help. These are going to cross reduce. This is going to give me 7. This will give me 5. They both divide by 2. So I'm going to end up with 49 over 15. Final answer. Question B and question C bring into the idea, well, what do we do about bed mass, right? So remember, with bed mass, brackets, exponents, and then multiplication, division, addition, subtraction. And multiplication and division are always just done left to right, okay? So here we go, 6 over 5 divided by 9 over 10 times 1 over 20. So this is division, so we're going to change this to multiplication, and we're going to flip this fraction. We're not flipping the whole thing because it's not divide by the whole thing. So this becomes 6 over 5 times 10 over 9 times 1 over 20. And now this is straight across the top, straight across the bottom, multiplication, and we can do some cross reducing. I can see that this 6 and this 9 are going to reduce. This is going to give me 2 and 3. I can see that this 10 and 5 are going to reduce. This is going to give me 1 and 2. And I can see this 2 and this 20 are going to reduce. That's going to give me 1 and 10. And I can see that this 10 and this 2 are going to reduce. That's going to give me 1 and 5. Now we just have to remember what all parts we're multiplying together. 1 times 1 times 1 is 1 on my numerator. 1 times 3 times 5 is 15 in my denominator. Done. And then question C. Question C, 6 over 5 divided by 9 over 10 times 1 over 20. But 9 over 10 times 1 over 20 is in brackets, so I need to do this first. So 6 over 5 divided by, this is going to be 9 over 200. Okay. But then it's division, so we're going to multiply. So this is going to flip 6 over 5 times 200 over 9. And then we can do some reduction. 6 and 9 is going to reduce to 2 and 3. 5 and 200 is going to reduce to 1 and 40. And then I think that's all the reduction that we have. So then we go 1 times 40 is 80. 1 times 3 is 3. 80 over 3. Final answer. Now the key with division of polynomials, or well, not polynomials, but division of rational expressions, is that we still have to do our non-permissible values. But as soon as we see a division, okay, we have to be careful of what we include for non-permissible values. Whenever a variable ends up in the denominator of a fraction, it's going to lead to a non-permissible value. So right now, here, this is a constant times b squared. So that means b cannot equal 0. This is a constant times b, which is also b cannot equal 0. So as it stands right now, b cannot equal 0 is our non-permissible value. We're dividing, so we're going to change that to multiplication. So 16a over 9b squared times 15b over 32a squared. But this leads to this a now being in the denominator of my fraction, which is now going to give me a new non-permissible value. So whenever we flip that fraction, we have to include any variables that end up in the denominator of the fraction. Now I can try and do some reducing. Top to bottom, 16(9) doesn't work, but crisscross, 16(32). This 32 will change to 2. This 16 will change to a 1, dividing by 16. Both 9 and 15 divide by 3, so this will be 5 and this will be 3. This A will cancel out with one of these A's, so this is now just A. This B will cancel out with one of these B's, so it's now just B. So we end up with, it looks like 5 over 2 times 3 is 6, AB. 5 over 6AB, our final answer. Let's look at question B. So again, we're going to multiply left or right. We see a division here, which means I need to flip this one. So I can do this division and flip and multiply right now, just to get it all set up so that it's all multiplication, and then I can start cross-reducing. Before that though, I'm going to do my non-permissible values. Here, x cannot equal 0. Here, z cannot equal 0. Here is already x cannot equal 0. It's already in there. And here is z cannot equal 0. So that's all of them. Okay. So I'm just going to rewrite this. I'm going to go -5. -5xy cubed all over 7xz cubed times 2z all over 15x times -21z to the 4th all over 10x squared y squared. Now it's straight across the top, straight across the bottom. It's all multiplication, so I can start doing some reduction. This negative and this negative will cancel each other out. Negative times a negative is a positive. This 5 will reduce with this 15. That will give me 3. This 7 and this 21 will reduce. That will give me 3. This 2, this 10 will reduce. That will give me 5 here and 1 there. Of course, there's 1s here. This x and this x will reduce. This z cubed and this z to the 4th will leave 1z on the top. This y cubed and y squared will cancel. This cubed will be a 1 on the top. I think that might be just about it. So now we combine straight across the top. It's going to give me 3z squared. Oops, I forgot the y. 3y z squared all over 15x cubed, I think. So at this point, we double check. This 5 and not 5, this 15 and this 3 will also reduce more. That will give me 1 and 5. So really our final answer, yz squared all over 5x cubed. Then that was it. Now we flip the page. The next page, example number 3. And what does it say? There's a little blurb at the top. Oh, at the bottom. Sorry, we're not flipping a page yet. These are just some rules. So consider the division A over B divided by C over D, where A, B, C, and D are variables. For the rational expression A over B, the non-permissible value is B cannot equal 0. For the rational expression C over D, D cannot equal 0. The first step in simplifying this is to invert the divisor and multiply to obtain this. So now you can see C becomes a denominator. So we also have to say that C cannot equal 0. Okay, so that's just a refresher of that rule or whatever that we just went over. Now we over the page. And this just says all the same stuff again. Any variable which appears in the denominator at any stage in the simplification should be considered a non-permissible value. So like I said, as soon as you flip it, you have to include it. Question 3, says state the restrictions on the variables in class example 2. Well, this is the same example that we already did, and we've already stated the non-permissibles, so we don't need to redo that, which is awesome. And then we move into some more complex questions. So you can see that these complex questions, if they're factored, well, we can start canceling factors after we flip. Sometimes we're going to have to factor our numerators and denominators so that we can cancel those factors. And then, of course, it just gets more complicated, right? More factoring, more things to do. So looking at example 4a, non-permissible value. Here is going to be 2. Here is going to be -3. There is going to be 0. There is also going to be -3. Okay, so x cannot equal 2, 0, or -3. Okay, easy as that to find them once everything is factored. Okay, now this is division, so I'm going to flip this. I'm going to flip this and multiply, so this becomes x plus 1 all over x minus 2, x plus 3 times x plus 3 all over 2 bracket x plus 1. Now it's multiplication. Now I can start to cancel. This x plus 1 and this x plus 1 will cancel. This x plus 3 will cancel with this x plus 3. That's going to leave me x times 2, divided by 2 times x minus 2. Question B. 4x plus 12 divided by 3x plus 12, all divided by that. We can read it. Okay, so I'm going to rewrite this question at the same time as I factor everything. Okay, so 4x plus 12 is going to factor to 4x plus 3. 3x plus 12 is going to factor to 3x plus 4, divided by 3x, x plus 3 over x plus 4, x plus 4. Notice I've expanded that exponent. Now I have to determine my non-permissibles. Look, x plus 4, x plus 4, x plus 4. So x cannot equal -4. So there's my non-permissibles right now. Did I find my non-permissibles once I flipped over here? Don't think I did I? No, I know I didn't. Right here. Because this flipped, right? This is x plus 1 now. I have to add in -1 as a non-permissible. Good catch, Kaz. Nice, thanks. So before I flip this, there's my non-permissible, -4. Now when I do flip it, I get 4 times x plus 3, all divided by 3 times x plus 4 times x plus 4, x plus 4 over x, 3x, x plus 3. Now I have this new non-permissible, x plus 3, so x cannot equal -3 also. And now I can cancel. X plus 3 will cancel with x plus 3, x plus 4 will cancel with x plus 4, and that is about it. So now we get 4 times x plus 4 over 3 times 3x is 9x. And that would be complete. Okay, now we get into some fun stuff. Look at that. Example 5. Perform the indicated operations for each of the following expressions. Express your final answer in lowest terms and identify non-permissibles. So remember, we can only get non-permissibles after everything's factored. So let's look at A. I'm going to factor A at the same time as I flip this and factor it. Okay, so lots of steps all combined in one here. Oops. So let's factor 4x squared minus 12x. That's going to give me 4x, x minus 3, all over x squared minus 9 is x plus 3, x minus 3. Difference of squares. Times, this is now my numerator. Oh, actually, you know what? I don't want to flip it. I don't want to flip it because I'm afraid I might miss some non-permissible values. So I'm going to leave it. Oh, what's going on here? Oh, we end up at the very beginning again. Must be hitting something funny with my pinky. Where are we? Not there. We are not. Oh, this is where we are. Bye. Smaller. Yep, there we are. Right. Okay, so I don't want to flip that right now. I'm going to factor it. I'm going to get 7x squared x plus 1 all over x. Two numbers that multiply to 3, add to 4, plus 1, x plus 3. There. Now, my non-permissibles, -3, +3, -1, -3. X cannot equal plus or minus 3 or -1. Okay, that's as it stands right now. But as soon as I flip, so now it's going to become 4x, x minus 3, all over x plus 3, x minus 3, times x plus 1, x plus 3, all over 7x squared, x plus 1. I now have a new non-permissible, but x plus 1 was already in my non-permissible, so I don't have to include anything else. So I would be worried about this one because it's new, but I don't have to because it was already in there. Okay, now I can start to cancel. Color red. X minus 3 is going to cancel with x minus 3. X plus 1 is going to cancel with x plus 1. X plus 3 will cancel with x plus 3. This x will cancel with one of these x's, leaving me with 7x. So that's going to leave me with a grand total of 4 over 7x. They're done. Question B. So you can see here, we've got a bracket. So I need to simplify this before I do this flip and multiply. So what I want to do first is I want to factor everything and then determine my non-permissible values, and then simplify the bracket, simplify this bracket, and then flip and multiply. Okay. It's a bit of a long process. 20m squared, 20m squared plus 30m is going to factor to 10m, 10m, m plus, no, not m, 2m, 2m plus 3, all over. This is difference of squares, but it's backwards, so I'm going to factor out a -1, and that'll leave me with 2m plus 1, no, 2m plus 3, 2m plus 3, 2m minus 3, divided by, big bracket, 11m. If I take out an 11m, that's going to leave me m squared minus 1, which is difference of squares. So this would be m plus 1, m minus 1, all over, factor by decomposition, 2m squared minus m minus 3, two numbers that multiply together to give -6, add together to give -1, -3, +2, 2m squared minus 3m plus 2m minus 3, factor out an m, 2m minus 3, factor out a plus 1, 2m minus 3, 2m minus 3, m plus 1. This is going to factor to 2m minus 3, m plus 1, times 2m plus 3 over m plus, no, minus 1. Minus 1. Whew. Simplifying the big bracket, I'm going to cancel. I am going to cancel almost nothing. M minus 1, m minus 1, m plus 1, m plus 1. Oh, more than nothing. And that looks to be about it. Oh, I'm going to back up, back. I'm backing up because I need to do my non-permissible values first. This will give me a non-permissible value of negative 2 over 3. This will be positive 2 over 3. Sorry, 3 over 2. 3 over 2. 3 over 2. Negative. Positive 3 over 2. Positive 3 over 2. Negative 1. Positive 1. That's it. So plus 1 minus 1. Plus 2, 3 over 2 minus 3 over 2. So over here, I'm going to go my non-permissible values. M cannot equal plus or minus 1 or plus or minus 3 over 2. Now I can erase this. And again, maybe you're still at the step or the point where you're doing these off to the side somewhere, and it would look like this. 2m minus 3 cannot equal 0. Add 3, 2m cannot equal 3. Divide by 2, m cannot equal 3 over 2. So that's how each of those were found, right? Now I can cancel inside my bracket. Plus 1, minus 1, minus 1. That will leave me with 10m, 2m plus 3, all over negative 1, 2m plus 3. Oh, I see it canceling that I could have done already. 2m minus 3 times, I'm going to flip now, 2m minus 3 over 11m, 2m plus 3. Good. Now I can cancel again. This 2m minus 3, this 2m minus 3, this 2m plus 3, this 2m plus 3. That's an 11m, that's a 10m. These m's, I'm going to be left with, I am going to be left with 10 over 11, 2m plus 3, and something has to be negative. Sure, there. Negative 1. Question 6, example 6. 10 divided by a minus 12 divided by 2 over a, all divided by 5 over a plus 4. State the restrictions on a. So I like to start these questions by first writing it out on a single line. 10 over a minus 12 over 2a plus 1 divided by 5 over a plus 4. And then there's all kinds of work that needs to be done first, right? Because this is a subtraction, I need a common denominator and I need to simplify. This is an addition, I need a common denominator, I need to simplify. It's almost like these are in their own brackets because of that plus minus thing. So remember, it's all of this and all of this. Okay, so that's a BEDMAS thing, right? So I need to bring in what I remember about addition and subtraction. My common denominator on this side is going to be a and 2a plus 1, a and 2a plus 1, boom, minus, boom. 10 was already there. I multiplied in a 2a plus 1. The 12 was already there. I multiplied in and a. Divided by, so this is in a bracket. Divided by, put this over 1. Common denominator is a. So it's 5 over a plus 4 over a, 4a over a. I have to multiply by a. This is also in its own bracket. On my left-hand side, I'm going to expand and distribute. Oops, no, bad arrow, bad line. There. And there we go. So this is going to give me 10a plus 10 minus 12a all over a bracket 2a plus 1 divided by 5 plus 4a all over a. My non-permissible values, a cannot equal 0. 2a plus 1 cannot equal 0. So subtract 1, 2a cannot equal -1. A divided by 2, a cannot equal -1/2. So far 2 non-permissible values. I'm going to simplify the top of my numerator on this side at the same time that I'm going to flip and multiply this side. This is going to give me -2a plus 10 -2a plus 10. Oh no, I screwed that up. That's not -2 because this should be 20. 2 times 10 is 20. 20, so this is 8a all over a bracket 2a plus 1 times a over 5 plus 4a. But that's backwards. I don't like that, so I'm just going to rewrite that the right way around. Okay, so 4a plus 5. Boom, boom. This a will, got a new non-permissible value, 4a plus 5. 4a plus 5 cannot equal 0, minus 5, 4a cannot equal -5. Divide by 4, -5/4. A cannot equal -5/4. So a new non-permissible. Now I'm going to cancel this a with this a, and you can see that this factors, okay, because everything divides by 2. So now I have to factor that. 2 over 2a plus 1, not 2, sorry, 2 times 4a plus 5 times 1 over 4a plus 5. Look, those are going to cancel, top to bottom, leaving me with 2 over 2a plus 1. Bada boom, bada bing, done. Okay. That brings us to the end of lesson 6, checking Stellantis and figuring out which questions need to be completed. And we shall see you next time.